Hello everyone, this is Peter from Team Embarrassing Engineering again, reporting back from the Georgia Tech RoboJackets headquarters. And I'm with my new robot, Carbon. It is once again the day before the competition, and I'm running really late. However, before this robot gets smashed into a million pieces tomorrow, I would like to do a short breakdown. The premise of this robot, as the name suggests, is to use as little custom metal components as possible, and to design a robot with a hub motor that could be easily accessible for everyone and easily manufactured. When I set out to design this robot, I included only one single custom metal component, and it is this weapon bar right here, which is just laser cut 1/4 inch AR500 steel. I hope by experimenting with designs like these, I can make hub motors more accessible for everyone and make combat robots in general lower cost and lower entry barrier. During the build of this robot, there are some things that went quite well, and then there are other things that went terribly wrong. Short disclaimer. This robot was built by me in the middle of exam season while I'm really sleepy in 2 weeks. So any good results probably won't end up being good for long. So for the breakdown, let's first start with the things that went well. And the first thing that I think went quite well is this new hub motor design. Unfortunately, I cannot open the robot up right now because of something that went really wrong. I'll go over that later. But this is a new hub motor design that I was thinking about that doesn't require as much complexity and as much custom machining. It runs a live shaft, the same shaft that comes with the motor, unlike most hub motor designs. With most hub motor designs, what they do is they would take the live shaft off of the motor, they would take the bearings inside the motor out, and then they would put a dead shaft through and run bigger bearings. However, with this design, I'm thinking usually with the dead shaft designs, it's very difficult to align the hub with the stator properly. So I kept the live shaft. As you can see, it spins with the weapon. This is the stock live shaft from the motor. The motor I'm running is a Scorpion Power Systems motor with a very long shaft that goes all the way through the bot, so top to bottom. That live shaft is not taken out, so you do not need to replace the bearings and you do not need to redo the alignment. The main bearings that then support the weapon, because the shaft is quite weak and the bearings inside is quite weak, are outside. So there are two very large main bearings. They are encased in the chassis at the moment. So the weapon attaches to this 3D printed plastic hub. This is printed out of nylon and then filled with a plastic resin material that helps with layer bonding, hopefully. This is the first time I've tried this. But then outside of this hub goes two large bearings, which is then encased by the clamshell chassis. That is how most of the forces should be supported. So hopefully there will not be as much stress put onto this shaft. The shaft is mainly here and the collars to keep this robot from opening up in the clamshell and to mainly take the vertical forces in compression and tension. The shear forces will be taken hopefully by the big bearings, which will ensure that this system be durable. That I think went quite well. The other things that went quite well I think is the drive and the wheel guards. Those were printed quite nicely, also out of nylon, and they go into the chassis quite nicely. The wheels, these are currently testing wheels, but it is the first time I've done latex coating over the foam wheels to get more grip. I have these latex coated wheels, but currently I'm not running them because I was doing fit testing. The other thing that went well in this robot, I think, are the electronics. The motor, the battery, the ESCs, the drive motors, they're all quite standard. It's the same configuration as I run on Tekkadan, except the main difference is I'm running 22mm gear motors. Again, unfortunately, I cannot open up the bot right now, so I'll just explain what is inside. The wires for the motor runs from here, which is where the stator is above the entire mechanism, and it runs through the top into the chassis. The battery is located in the chassis, as well as all the speed controllers and the drive motors. The drive motors are just clamped down, so instead of having to have a custom motor mount, because this chassis is a two-part clamshell, the motor sits right in between the two, and when the chassis gets clamped down, the motor gets held in place both left and right, and also torsionally, so there's no worry of the motor falling out. Now for the things that didn't go very right. Let me flip the robot around, and you can see there is a big hole in the robot. Why is that? Well, there's a few things that went wrong. The first thing is this chassis itself. These plastic chassis. They look quite beautiful because they are printed from our backup printer, our Stratasys Pro printer at the makerspace. But the original plan was to print these out of nylon, the same material I have making the wheel guards and the hub. But the nylon prints blew up the extruder. I think they clogged, and then the feed kept going, which caused the molten nylon to just spew into the extruder and into the feed housing. It was really gnarly. I have a photo of it. But yeah, so our printer that was dedicated to print nylon was out of commission, and the other printers, they didn't want to run nylon there because we were scared of another failure happening. And that was 2 days before today, so 3 days before competition. So we didn't really have another printer at hand that could do nylon, and we didn't have time to fix that printer. So we had to resort to a different printer. We had some professional printers working in ABS. The Stratasys professional printers, they were working on ABS, so we printed these chassis out of ABS. That was the first thing that went wrong. It's not nearly as strong as the proposed nylon, and it's probably going to shatter into a million pieces, unfortunately. We'll see in the competition. But yeah, that was the first thing that went wrong. And then the hole. The original plan, of course, was to have this clamshell just open up every time we want to change batteries or replace electronics or service the electronics. However, earlier today, I was putting the screws in for the clamshell. This one is fine, but this one is stripped, this one is stripped, and the one over here is completely snapped. This was because when I was installing it, I was using a proper bit and a slower drill, and then when I came over here to put the battery in, I used a brushless drill that was running much faster, and I was running a smaller driver bit, and that caused the 4 screws to be completely destroyed. And now I can't open the clamshell up anymore. So now my robot's completely stuck in this configuration. I can't open anything up. I can't change the weapon. I can't do anything opening the robot up without pulling the 4 screws out and then thus ruining these prints. So I chose to go with a Band-Aid stopgap solution here before redoing this robot, since it's competition literally tomorrow. I cut a piece of plastic. This is a HDP, thin sheet of HDP, 32nd inch, and put 4 screws into the 3 screws into the chassis, and cut a hole into the chassis so I can access the chassis internals, and I can put a battery in, I can plug the battery in, and I can access the electronics. So yeah, this is a very stopgap solution. For the next build, I'm going to use different screws. I'm going to have slightly looser tolerances for these self-tapping screws. The original idea was to have plastic, of course, and just run 4 self-tapping screws, but the friction was too high and the drill was running too fast. So unfortunately, this was stuck in this configuration, and we had to use this back panel that is just going to hold our electronics in and look ugly. But yeah, this is a very short explanation. I'm sorry. I'm gonna have to head home, get some sleep, and head out to the competition tomorrow. Thank you for watching.